Hello, Assalamualaikum, and very good morning, good evening to all my friend there. So today, okay, my name is Ahmad Anwar Zainuddin. I'm from Manipur International University. So I would like to present my work. The title is Relationship in IoT and Big Data Analytics, the opportunity and open challenges. So this is my outline. All right, so let's see what is the application of big data. Big data is a scale of data, diversity and complexity, require new architecture, techniques, and as shown in this figure, a collection of data that is huge volume. It is a data of such a large scale and complexity that it cannot be easily stored or handled by any conventional data processing tool. The algorithm and analytics to manage and extract value and hidden knowledge from it. The concept of big data is problematic to the pinpoint, not least because data that appears to be massive, impact today almost surely appears small in the near future. And the complexity of the big data, some practitioners argue that massive data set are not always and the small data set are always simple. They highlight that the intricacy of a data set is significant factors in determining whether it is big. The big data is the new generation of technology and architecture designed to economically extract value from very large volume of a wide variety of data by enabling high velocity capture, discovery, and analysis. The most critical big data problem is that revealing an incentive from informational collection of colossal measurements. So our mapping study intends to bridge this gap. So we intend to provide a wide overview of the state of the art in big data analytic research for all education level to gain an insight into the core approaches taken and the challenges with that remain, to identify the main research gap as well as to make few recommendations for future works. So the main research question driving our study are number one, what is an overview of the state of the art in big data analytics? Number two, what are the trends in the scale and application landscape of big data analytics? Number three, what are the current and future trend use cases in IoT and big data in addressing the massive data sets? Number four, what are the opportunities and open challenges currently employed and future trend to address the application? Right, so this is the big data analytics. So far, when we learn about the Internet of Things, IoT, enable physical object to arrange in a technical system to expand its usability in terms of ease and time consumption. It is to transform the idea of bridging the gap between the physical world and the machine world. The number of connected devices is increasingly enormously, and many predictions have been made with this regard. So far, this is the what there is a need to address the progress of implementing IoT application in education, which can give a hint of the challenges and limitations yet to face in the concerned aspect. Several existing analytical systems such as number one, real-time analytics, offline analytics, memory level analytics, business intelligence, and finally business intelligent analytics. Let's see the existing analytics system. This system data sources are growing in length, speed, as well as complexity. This figure shows the example of an IoT system. Analysis of this enormous amount of data produced at such a rapid pace can produce a lot of useful data and can also be applied in other fields. This includes smart city technologies, smart transport, and grid networks. and smart meter for electricity, and also tracking devices for remote patient healthcare. Big data analytics is probably evolving as a significant key IoT program to improve decision making process due to the connectivity between devices provided by the IoT. Okay, so next is the relationship between IoT and big data. As you can see, phones, data, and networking are all about IoT. The true benefit of the Internet of Things, IoT, is the development of smarter goods, the provision of smarter insights, and the provision of new business results. As millions of devices can connected, a huge inflow of big data will be caused by the Internet of Things. Visualizing and uncovering knowledge from different type of data, contextual, dark, real time, and the application is the main challenge for today. Right, let's see the big data analytic method. An organization needs a effective method to transform vast quantities of assorted data into concrete understanding to promote evidence-based decision making. So the scope for the use of big data is limitless, but constrained by the availability of big data analytics, technology, resources, and skill. So far, the big data analytic refer to the approaches used to analyze and gain intellect from large data set according to several authors in many publications. In the whole process of insight attraction of big data, so the big data analytic may thus be viewed as sub-process. It is certain that big data needs the best method and technique to be efficiently and competently evaluated and categorized in order to achieve its goal and progression in the market setting. So this is the IoT architecture for big data analytics. The architectural concept of IoT has several definitions based on IoT domain abstraction and identification. It offers a reference model that refines relationships among various IoT verticals. The architecture is achieved by seamless ubiquitous sensing, data analytics, and information representation with IoT as the unifying architecture. There is several cases in IoT and big data. Number one is big data smart metering. Smart metering is used to generate a large amount of data from different sources. It is a device that electronically records utilization of electric string data between the meter and the control system. Utility companies must be proficient of advanced analytics and high volume data management. Next is big data smart metering. Uh, for the smart metering, for the smart city model, this principle is utility, rain, fog, and several other causes interrupt the old transportation network. They are focused on the processing of picture, which is why they are so fragile. Uses radio frequency identification (RFID) for vehicle tracking and analysis. In addition, this technology can be used to control traffic congestion. Using satellite data linked to each device, we can optimize route handling for various vehicles to enhance lead quality. Big data smart supply chain embedded sensor tools can connect bi-directionally and provide remote accessibility to over 1 million elevators worldwide. In transit, visibility is another use case that will play a vital role in future supply chains in presence of IoT infrastructure. Next is big data smart agriculture. Sensors are the actors in the smart agriculture use case. They are installed in the field to obtain data on moisture level, trunk diameter of plants, microclimate condition, and humidity level. This data pass through an IoT gateway and the internet to reach the analytics layer. All right, so the opportunities for IoT and big data analytic, we can see in e-commerce, big IoT data analytic has widespread application in near every industry. The main success area of analytics are e-commerce, revenue growth, and accuracy of scale, forecast result, conversion of big data with IoT, bring new challenges and opportunities to build a smart environment. Next, in logistics and retail, so far IoT is required to play a role as evolving technology in logistics and retail. In logistics, RFID keeps track of containers, pallets, and crates. Data analytics enable enterprises to gain insight from voluminous amounts of data produced through IoT technologies. Finally, in the smart city, big data collected from smart city offer new opportunities in which efficiency gains can be achieved. Numerous devices link up to the internet in a shared information and smart environment. So the open challenges and future direction. So far, privacy issue critical because there is a huge risk in IoT and big data analytic concerning user personal information. Conscious users are not able to simply access these services on the go with current conscious text user and privacy. So the need for prime solid service level agreement or SLA must provide a confident and standard SOP in terms of handling user personal details. So far, given the enormous of data collected, transmitted, and exploited in IoT big data operation, the probability of security risks is also rising. In the current IoT and big data system background, measure described such as in primitive as previously discussed. IoT and big data platform are seen as emerging and can be seen as a more recent phenomenon that cause issue by utilizing old algorithm and method that are not well designed to tackle new technologies. Right, so next is open challenges and future direction. So far, data mining used for feeding patterns and description need for the data generation. So far, evaluation of big data and cloud computing platform has brought challenges of data exploration and information extraction. Large data set comprises more abnormalities and ambiguities that require additional processing steps. So far, the researchers have introduced parallel and sequential programming model and proposed different algorithms to minimize every response time while dealing with the big data. The need to devise algorithms remains to provide compatibility with the latest parallel architecture. So this bottleneck of data mining methods has become an open issue in big IoT analytics that should be addressed. Okay, and this figure summarizes the data mining which is used for feeding patterns and description. These data are needed for data generation, high speed of data access, for both reading and writing, which consists of variety of data can be problematic. All right, so I conclude that the relationship between IoT and big data is currently at a point where vast volume of data at a high frequency need to be processed, transformed, and analyzed. Within the background of big IoT data analytics, several surveys are conducted. We also discussed the recent solution for IoT and big data analytics, and addition and architecture for analytic of big IoT data is proposed. In addition, also some credible cases of usage have also been provided in this presentation. And finally, the current solution for broad IoT data analytic remains in their early stage of growth, also presented. So in the future, there will be a need for real-time analytical solution that can provide fast insight. So far, I think that's all for my presentation. Thank you very much and bye-bye.